in this example, I want to basically cover most of the operations that we do on vectors. The first one, use the given vectors A and B and draw the following vectors: A plus 1/3 B, 2B minus 1/2 of A. Okay, so this is the vector A, this is the vector B. I'm trying to add them up. Okay, so I have the vector A. Let me graph A in the same direction, the same length, the vector A. And now this is 1/3 of B. So I have the vector B. 1/3 is a positive number that is multiplied to the vector B. So the direction of B doesn't change. It would be the same direction, but the length would be 1/3. So let me kind of divide B. So 1/3 B would be something like this. So this is 1/3 B. Okay, when I want to add them up, two vectors, I'm gonna graph the first vector, and the second vector would be at the end of the first one, the same direction. This is 1/3 B. And then for the addition, I'm gonna start from the beginning of the first vector, and I'm gonna graph to the end of the second vector. So this would be A plus 1/3 B. Perfect. How about the second one? 2B minus 1/2 A. Okay, so I have B. 2 is a positive number that is multiplied by B, so doesn't change the direction of B, but just the length would be reduced to 2B. So 2B would be like this. This is 2B. Okay, so I'm gonna have 2B. Okay, and then, oh, it is not exactly the same direction. So let me make it exactly the same direction of 2B. And then negative 1/2 of A. Okay, negative 1/2 now is a negative number, so the direction would change. Okay, and also the length would be reduced to half of it. So the half of A would be at the same as this one, and then it would be negative. So instead of graphing like this, I have the opposite direction like that. So this is negative 1/2 A. So now I have 2B, and then at the end of the first vector, I'm gonna have the second vector, negative 1/2 A, and I'm gonna assume that I have a addition. The first vector, and then at the end of the first vector, I'm gonna graph the second vector, and then I'm gonna start at the beginning of the first vector, and I'm gonna go to the end of the second vector. So it would be 2B minus 1/2 A. Okay. Done. How about the second one? Let A be that vector and B this vector. Find 2A plus 3B and the magnitude of A minus B. So this is the component-wise vectors. This is the component-wise representation of the vectors. So I have 2A plus 3B. So 2 is going to multiply by the vector I plus 2j minus 3k, and then plus 3, and then b, the vector b is negative 2i minus j plus 5k. So let me multiply everything. It would be 2i plus 4j minus 6k minus 6i minus 3j plus 15k. I just distribute the numbers. And then look at here, I have 2i negative 6i. So together it would be negative 4i. Then I have 4j, negative 3j, so I have just 1j. Then I have negative 6k plus 15k. So together I have plus 9k. Okay, that's it. That's the vector 2a plus 3b. Okay, now how about a minus b? A minus b. Okay, I can do the same thing, but it's easy for me to write them in the kind of a vector notation. 1, 2, and negative 3 is basically the representation of the vector A, and I have minus the second vector. The second vector here is negative 2, negative 1, and then 5. So I have what? I have 1. I'm gonna basically add the first components and then second components and third components. So let me just keep writing the first vector. And let me distribute the negative into here because I don't want to forget the negative sign. So it will be 2, 1, and then negative 5. Now I'm going to add the first components, 3, 3, and then 2 plus 1 is 3, negative 3 minus 5, negative 8. Awesome. Now I'm looking for the magnitude of that, a minus b. The magnitude of any vector would be the absolute value of the first coordinate square plus the second coordinate square plus the third coordinate square. So it would be 9 plus 9 plus 64, which would be 18 plus 64. It would be what? 12, 182. Okay, good. So let me just keep it as that. This is the second one. Now the last one. Find a unit vector that has the same direction as this vector. Okay, so what do I have in here? I just have one vector in here, which is 8i minus j plus 4k. Okay, and I'm looking for a vector that is called unit vector. So what is a unit vector? Unit vector is basically a vector of size 1. Okay, how can I find this? I want a vector of size 1, but in the same direction of the given vector. Okay, this one. So first of all, let's see what the length of the given vector is. So the length of 8i minus j plus 4k is the square root of 8 squared plus negative 1 squared plus 4 squared. So it would be 64 plus 1, 65 plus 16. So let me write this. 65 plus 16, which would be what? 11, and then 81, 9. Okay, so the length of the given vector is 9. Now I'm looking for a vector in the same direction. So basically a scalar multiplication to this vector, but because I want to keep the direction the same, I don't want to switch the direction. I just need to multiply a positive scalar, a positive number to that vector. So what is the positive number that I'm going to multiply it to? It's 1 over 9. So I'm going to multiply 1 over 9 to the vector 8i minus j plus 4k. Okay, so I'm not going to do anything. So it would be 8 over 9i minus 1 over 9j plus 4 over 9k. Let me write in another notation. 8 over 9 plus, the second component would be negative 1 over 9 and 4 over 9. So unit vector of size 1 in the direction of a vector, say v, is this. 1 over the length of v times the vector v itself. The length of any vector is a positive number because it's basically square root, so it's a positive number. So I'm going to multiply a positive number to the vector, and believe me that the length of this vector is 1. Would you like to try? Let's see. What is the length of this vector that I already calculated in here? This is the unit vector that I was looking for. And I claim that the length here is 1. Let's check. 8 over 9 square plus negative 1 over 9 square plus 4 over 9 square. Let me do a little bit of algebra. It would be 64 over 81 plus 1 over 81 plus 16 over 81. So the common denominator would be 81. I'm going to add up 64 plus 165 plus 16, 81. So square root of 1, which is 1. So the length of this vector is 1, and it is in the same direction because I multiplied by a positive number.